name is Ken Levinson. I'm the Executive Director of the Passivhaus Network, and I want to welcome you all here today. As folks are coming in, I'll do a brief introduction here of the Passivhaus Network and kick us off. So welcome to Optimizing Form and Function, Meet Single Point Access, Blocks, an Old New Tool in Sustainable Placemaking. I have to admit, that's my wordy description. Mike does not need to take responsibility for that. It's all on me. And we're really happy to have Mike Eliason here from Larch Lab for this presentation. Let's see. A brief word about the network. So we are a national nonprofit. We have members across the country, around the world even. We have regional chapters, and we are affiliated with the Passivhaus Institute in Darmstadt, Germany, and part of the International Passivhaus Association, and work with other affiliated groups from Passivhaus Canada, Passivhaus California, New York, and the Passivhaus Trust, and so forth around the world. It's really a global brain trust of knowledge. And we are also happy to work with the North American Certifiers Circle, a group of Passivhaus certifiers working in the United States that we're really happy to support. We hope you become a member. It's really about taking the global knowledge sharing, applying it to regional contexts and local applications, and making it work. We all need to be doing it together. The Passivhaus Network is really an educational organization, nonprofit, and we're focused on training because we understand that it is through education and training and the conversations that come out of that change our vocabulary, change what kind of questions we ask, change our expectations. It really changes how we think and work with buildings and with each other as teams. We're happy to work with the Building Energy Exchange on introductory courses. We offer course certification courses, the Certified Passivhaus Designer course on demand, and also in hybrid formations. And we work with EMU to provide the Certified Passivhaus Tradesperson course. There are advanced specialized courses, of course, as you get into particular aspects. And we also really consider certifying buildings as a critical aspect of your education in Passivhaus. Like an apprenticeship, like graduate school, like just getting in and doing it, there's so much to learn, and particularly when you're working with certifiers from the beginning of the process and learning the optimizations, learning from what other people have done before, that building on that institutional knowledge, it really gets you ahead much quicker. So we encourage you to take a look at our educational offerings and sign up after this session. Let's see here. Right, so we have coming up very soon a series, as we're coming out of the pandemic, of hybrid trainings on this Certified Passivhaus Designer. We're focusing initially here in New York City, Maine, Connecticut, and Boston, working with our regional partners in these areas, and partially on demand online and partially in person, and figuring that out and working with cohorts regionally based. And we're looking forward to doing more of these around the country. I want to mention the PH ribbon, which is the Passivhaus Embodied Carbon Emissions Calculator. It is something that is embeds with the PHPP, and you work hand in hand with the PHPP. So not just designing with an eye towards operational emissions, but combining that with embodied emissions and really being able to tackle total building emissions. We are in a climate emergency, and we want to use every lever that we can. In June, please join us for our national annual conference. 2022 this year, Passivhaus for All. We're focusing on these 4 buckets of fundamental ingredients of sustainability: efficiency, electrification, embodied carbon, and equity. It will be online on June 10th and in person and online on June 17th. So you don't have to go to Boston to participate, but if you are in the region, we sure hope you can show up. It's great to see people again in person. There will be registration and more information coming out in the next couple of weeks, so stay tuned. A quick thank you to our sponsors who we couldn't do this without. Passivhaus requires quality education and training. It requires intention and quality design and building. It requires quality components. And we're very happy to have manufacturers who believe in this and who support what we do. From insulation, like Owens Corning, Rockwool, and Aero Aggregates, to the enclosure, 475, Roadblocks, and Partel. HVAC, Zender, Swagon, and Mitsubishi Electric. And windows and doors, Alpin, Cascadia, Enersign, Intus Windows, Schuco America, and Wythe Windows. And finally, our service providers who are supporting us: Bright Power, AHA, Need Based, Stantec, Stephen Winter Associates, NYSERDA, and Cube 3. Thank you all very much. And we hope if you're out there and your business is focused on manufacturing, supplying, or service, you consider supporting the Passivhaus Network. So with that, I'm very happy to welcome you all here again to this PHN Presents with Michael Eliason. Really excited to get into this content. One of the things that is so special about Passivhaus that we're trying to punch up a bit is that Passivhaus really serves as a foundation for a wide range of goals and performance performance goals that people want to go for sustainably around urbanism, around the environment, socially, whatever it might be, and being able to draw those connections. And I think this presentation is one of those clear cases where we're going to draw Passivhaus, which is very core, well-defined focus on certain performance aspects, and see how it can interrelate and support wider goals, and how those wider goals can support Passivhaus, and really build on those synergies. Michael Eliason, who we were just chatting before we came on, I had the pleasure of meeting 10 years ago in 2012 in Hanover, Germany, at the International Passivhaus Conference there. Mike is a founder of Larch Lab. He's an architecture. Larch Lab is an architecture and urbanism think and do tank focusing on research and policy, decarbonized climate, adaptive low energy urban buildings, and sustainable urbanism. He's a writer, an award-winning architect specializing in mass timber, social housing, Bogruppen, urban co-housing, and eco districts. We should also mention he's fabulous on social media and did a terrific tweet thread storm on our fenestration symposium just last week. His career has been dedicated to advancing innovation, broadening the discourse on sustainable development, Passivhaus, non-market housing, and decarbonized construction. His professional experience includes extensive public work in both the Pacific Northwest and Germany, and we are looking forward to him bringing that experience to bear here today. So welcome, Michael. I will stop sharing.
Thanks for the introduction, Ken. Hello, everybody. Let me get my slides loaded.
Replace you with me. Oh, I should note before I go away, you have questions, put them in the chat. I will be pulling questions out of the chat and putting them into our discussion after Michael's presentation.
All right, we're good to go?
Go ahead.
Okay, hello everyone. Like Ken said, Michael Eliason, I'm the founder of Larch Lab. We're an architecture and urbanism studio based in Seattle. Also a little bit of a think and do tank, really interested in policy, advocacy, working with some of our colleagues in Europe as well on issues like mass timber, value-added wood industry, Passivhaus. I'm super interested in eco districts, something that we're really not that great at in the US, and I'll show a couple of examples later. In Baugruppen, which are kind of urban self-developed co-housing, and other forms of non-market housing like social housing and cooperatives. Try to live the what we preach. We're a car-free family. We have 2 kids. We get around by cargo bikes, and so kind of mobility, how we live, passive house, low energy buildings are all kind of interwoven in our life. So the theme of this is going to be a little bit about bureaucracy and codes and optimization. I consider myself a social democrat, but I absolutely loathe bureaucracy. And this is why. So if we look at the Seattle zoning code, the history of the Seattle zoning code, it starts off, very minimal. We're not a very old city, but our code is definitely lengthened over time. And these layers of bureaucracy are found in the zoning code. They're also found in the land use code. So 100 years ago, there was a very minimal land use code. Multifamily housing was legal in every parcel in Seattle. Most other North American cities had comparable regulations. And then, in the 19-teens, 1920s, zoning was introduced in the US. And it wasn't zoning in the form of like planning as you would see in, Germany or other countries. And Germany is kind of the founder of the modern zoning movement. It was really about like limiting what could go where and keeping things apart. And so the same kind of scope creep or bureaucracy creep that we would see with our zoning code is, it's in our land use code as well. Or sorry, I have this flipped. The previous was the land use code. This is the building code. And so the big jump was when we started doing performance-based stuff in the code. But things have changed pretty drastically. It requires a lot of specialization. Project teams have to have really deep and broad specialization. On top of that, we also have design review, the neighborhood guidelines. The Canadian building code is a little bit shorter. The Bavarian building code is significantly shorter. And this is just like the text of the building code itself. This isn't like the ISO or DIN or ANSI standards, right? Those are a whole other beast as well. So there's kind of like this increasing difficulty in doing these really simple buildings. And I'm a huge proponent of simple buildings, keeping things kind of compact. But to kind of compare that, this is a summary of the Basel zoning code. The numbers up here are the zone levels. It basically corresponds to the number of floors that you're allowed in a building, the FAR that you're allowed, the number of stories that you're allowed, how high your wall can be. And on top of that, they also have kind of a spring point from the wall for your roof angle, and then the roof is above that. And so that really opens up some interesting opportunities for expanding beyond just kind of like the basic zoning envelope that we would see in the US. Another thing to notice is that the building depth on these is relatively thin. So thin buildings, as a passive house person, low energy person, and someone who's interested in livability and how our buildings kind of reinforce or take away components of livability, I think that's pretty critical. So we'll talk about a couple of different forms of vertical access. The first one is the point access block. This is kind of the thesis of my work. Basically, this is you would have a single stair building, and we'll talk a little bit about that later, that all of the units are accessed from that single core. There's the single loaded corridor, which is where you have a hallway or an exterior passageway that units are accessed from. So you'll have like elevator, stair core, and then the corridor kind of going between. And then there's the double loaded corridor. Double loaded corridor is probably the most commonly used access arrangement that you would see in the US these days. It's hallway corridor down the middle, and then units parceling off from either side of it. And so we'll start with the double loaded corridor. It's fairly efficient. This plan is 87% efficient. So 13% is circulation, elevator, corridor, stairway, things of that nature. What this leads to is small units though. So you can't really get large units in here because you're having to, with the way we work in the US, economically compete with studios and one bedrooms, which go for a lot higher. There's also not the opportunity for cross ventilation. There's not the opportunity to get daylight on multiple sides. The closest you can get are corner units, and maybe you can have like a corner aspect where you can get a couple of bedrooms on that. I will note that I'm not a huge fan of double loaded corridors. You don't get a lot of respite from urban noise. So if this side of the building was an arterial, these people can't really open their windows because they have pollution, they have noise. And conversely, on the other side, maybe you're on the south side of the building, and in the US, external shades aren't really a priority. And so your building will be baking. or even on the west here in Seattle, the western exposure can be pretty harsh in the summer. Just a really quick example, Incremoison in Portland. Double loaded corridor, here's our corridor, stair, elevator core, stairway. You'll notice that most of these are 1 bedroom or studios. The exceptions are here on the corner. There's a 3-bedroom, there's a 2-bedroom, there's a 2-bedroom. So there's not a lot of variation in the unit sizes or types. And I'll talk a little bit about that in a minute. Now we'll go to the single loaded corridor. So again, buildings on one side of the corridor, stairway, elevator, stairway. This is not as efficient. This plan is only 84% efficient. I've seen less. You can get a diversity of unit sizes. So studio, 1 bedroom, studio, 2-bedroom, 3-bedroom are possible. You can get cross ventilation. So you can open up windows and doors on either side and go through. You can get daylight on multiple sides. And so this is a significantly thinner building than the double loaded corridor. This is a social housing project that we toured in Vienna a couple of years ago by Martin Traversberg. There's a huge rail track here. So what they're doing is they're using the corridor of the single loaded corridor here to basically act as a noise buffer. So here's our corridor situation, stairs, elevator bank, stairs, right? And all of the units are kind of parceled off of that. What's interesting is this is a much larger development. And all of these buildings here on the south side are all, they're connected point access blocks. And we'll talk about that in a second. And so the point access block is basically you have a building with a couple of units that are really just kind of spread out around the core of the building, the stairway and the elevator. In Germany, it's called the Punkthaus or the Spanner. And there are limits to the number of units. It does require more elevators at times, but what you get is you get a floor plan that is compact, or you get a building that is compact. You get a floor plate that is much more efficient. So this one is almost 94% efficient. And if you think about, if you're 8% more efficient than the double loaded corridor, plus you're an 8-story building, right? That starts to add up over time. You can get a diversity of unit sizes. There's the opportunity for cross ventilation. You can put the bedrooms on the quiet side of the building. So if you do live on an arterial, you're not sleeping with your windows open on the loud side, and you can have a better rest. I will note that noise monitoring is a huge aspect or a huge issue in the EU right now as they try to make cities quieter. It's not really anything that exists in the US, I think outside of some HUD projects. And so this is a recurring conversation that I've been having is, we're architects, we're designing buildings. Buildings need two means of egress. This is true, and in Germany and the rest of the world where they have single stair buildings, the second means of egress is actually the fire department. So they'll come and pull you out, and that's considered the second means of egress. So this is a project by Workshop A+D here in Seattle. In Seattle, we can do a 5-story point access block over parking or live, work, or commercial. They actually got a code mod to do another floor. So it's a 7-story building. The International Building Code, which much of the US uses, allows for a 3-story single stair building plus basement. There's a max on the number of units per floor, which is 4. There's a max common path of egress travel. So it's kind of, you come from the corner and go to the stair that has to be under 125 feet. In Seattle, so we can go higher, but there are more restrictions. Your building has to be 1-hour construction. We have to have a corridor. So I put this on here so you can see the difference. There's a corridor here that separates the stairway from the units. It's the same common path of egress travel. Again, max 4 units per core. What's interesting is we can do 2 of these. So you could kind of gang this together and have one on one side and one on the other and have 8 units. I believe the code language in New York is pretty similar to the IBC. In New York, you guys can use scissor stairs as 2 means of egress. In the IBC and in Seattle, it will only count as 1. So we can put a scissor stair, but we still need to get a 3rd stair in to do it. The Canadian National Code is also fairly restrictive on this point. You can do a 3-story townhouse, but the minute you put multiple units together, you can do max of 2 floors. The rest of the world is significantly different. Single stair buildings you kind of found the world over. They're extremely common. Single loaded corridors are also very common. The double loaded corridor is very rare. There are generally restrictions on the number of units per floor. Germany is 4, Austria is I think 8. There are travel distance requirements just like we had. Germany, it's 35 meters, which is 115 feet. the issue of doorways in the stairway varies. France, you have to have a corridor and a separated compartment for the stairway. In Germany, Switzerland, Austria, you can put the doors directly into the stairway. And that makes for some really interesting things. We'll talk about that later. And Seattle has to be sprinklered. Most of the world doesn't sprinkler buildings, at least low rise and mid rise. It is a higher rated construction than we need to do here. There are also requirements typically on the max floor area. And you could do this several times on the same lot. So it's not one instance. You could do, I've been like throwing up pictures of 16 and 20 point access blocks that are all connected, and just allowing a wide kind of diversity of unit types and sizes and things like that. I will note, so I was hired by the City of Vancouver to write a report on point access blocks as part of their thinking on redensification and re-compaction and small lot development, kind of unlocking small lot development. I view this as a means of unlocking a lot of small lot development. So concurrent with that report, Konrad Speckert is a Swiss architect in Montreal who was working on his thesis, which is online, secondegress.ca. I saw Konrad was on here, so he might answer any additional questions if anyone has them. And it's a fabulous website. He goes really deep into the code from a number of different jurisdictions and countries. And he has this manual of illegal floor plans. And it's just buildings that would be impossible to build in Canada because they're single stair buildings, they're point access blocks, and most of them are illegal in the US too. So it's just super fascinating to see what you can do. So the things that I love about the point access block, one is the super compactness. You get light on multiple sides. You could even have light on 3 sides. Cross ventilation, and I think cross ventilation is an important one. Going forward with climate change, we're going to get warmer. I was in a panel last year with a local developer who was saying that we don't need air conditioning in buildings. We don't need cross ventilation. It gets down to the 50s at night in Seattle, and so we're fine. And normally that's true. Historically, that's been true. Last year we had the heat dome, and for 3 days, the temperature in our unit did not drop much below 80 degrees Fahrenheit, and it was very unbearable. And we have cross ventilation, so if we didn't have cross ventilation, if we couldn't cross ventilate, it likely would have been hotter. And so there are, and we don't have, external shades are not common in the US. So we're not really doing things to kind of mitigate the heat gain that I think we're going to be seeing with a lot of, climate change. But I think that's something that we should be addressing, right? Like we should be testing our Passivhaus, our PHPP models, future-proofing them, gauging them against the warmer climate to make sure that we're not overheating. The other thing is that you get a larger diversity of unit types over a double-loaded corridor. So here, 3-bedroom. This is a 2-bedroom. Again, another 3-bedroom. It's rare to find these family-sized units in most double-loaded corridors because economically, it doesn't make sense. And so talking about the connected point access blocks, this is a development in Switzerland, huge, something like 150, 200 apartments. But each one of these little things here, these are the stair cores. If I do this, maybe that'll highlight it a little bit better, right? So this is kind of one point access block. This is another point access block. This is another point access block. And so you get all of these buildings kind of gang together. You get a diversity of units. You don't have a ton of people sharing the same corridor or elevator. So, this is kind of one of the things that we were thinking about, in COVID was, is it better to kind of parcelize, compartmentalize your building so that it's, safer from a transmission spread, standpoint. And I don't know, I'm not a mechanical engineer or a biologist who could speak to that. But why does this matter? So if we think about historically how we used to build, skinny parcels largely for tax reasons, but there are other reasons as well. These really wonderful mixed use, compact neighborhoods, flexible floor plans, shops. It could be family living above, later it could be rentals above, it can become condos later, right? So there's a lot of flexibility that was kind of inherent in the way that we used to build, again, humid scale, that fine grained urbanism, right? We traveled to Europe and Tokyo and other places to find that wonderful compactness that doesn't exist outside of a few places in the US or even North America. It's for us, it's really about car optional living as well. Like we don't ever want to own a car again. I hate driving. It's one of the things I miss about living in Germany was the ease of mobility. And so for us, it's recreating bike friendly urbanism, right? And so it's Again, going back to the passive house is kind of like our baseline, and then how do we stretch that so that it's not just our buildings that are low energy, but it's our lifestyles. Lloyd Alter wrote a really good book on living the 1.5C lifestyle. Highly recommend getting it if you haven't. And the other thing is most of these buildings are single stair buildings. This is the example in Barcelona. It's a late 1800s neighborhood. It's absolutely fabulous. These are all relatively small parcels, super dense, super deep. But again, most of them are point axis blocks. And it's just this really wonderful kind of gritty urbanism that you don't really find in the US much. And just, this is one of the buildings that is in example. It's Gaudi's Calvet House, single stair building, a couple of, courtyards. You can see this being like apartment here, right? And so if you're, relatively wealthy family wanting to live in the city in 1896 or whenever this was built, then, you would have that option. You wouldn't have to live in some suburban house. And the way that we build in the US is kind of this, I call it faking old urbanism, right? Like we do all of these tricks to make buildings look like they're not massive, right? So we'll use modulation to break up the facade, but it doesn't look good. Nobody likes it. There are other weird requirements. So Seattle passed an affordable housing bonus a couple of years ago. You got a height increase, but then we got really weird setback requirements. So there are passive house and embodied, implications in all of this. Your structure gets weird, gets more expensive. You have more surface area, which means you have more maintenance implications. It increases the energy or decreases the energy efficiency versus a box. The embodied carbon goes up. So it's kind of, we pull all of these weird things to make buildings look smaller, but in the end, they're not high performing. And sometimes they're just ridiculous. Toronto has its mid-rise guidelines. The last couple of years, I've seen some really amazing proposals to really kind of push as much as possible within these guidelines. Again, modulation, weird setbacks, deference to low-rise zones. This isn't really something that exists in most European cities. You could have a 6-story building next to a 2-story house and it's fine. But what you see though is that these buildings take up so much of the lot, and the way that they're oriented, there's really no buffer between the low-rise zone next door and the high-density building. And so we're creating these weird transitions with these expensive, funky buildings that don't perform well. And I think in a lot of ways, like they're not super livable. Like the units are really thin, really small, and super deep. And as we think, about passive house, there are a lot of implications to the surface area. So, just the act of adding loggia or balconies can make a huge difference. This building on the left has 27% more surface area, and then every one of these corners, it's a thermal bridge. It's another maintenance issue, but there's spatial qualities as well that have to be taken into account. Like the loggia is kind of protected. It's like the inset balcony. The cantilevered balcony is great. It's ubiquitous, but it's also a thermal bridge issue. So do you have the shock isocorb or something else that you have to put in? In Europe that's standard. Here it's still difficult to get developers to even get their head around it. And so comparing two buildings, these are kind of comparable size. This is Mies van der Rohe. This is the Denowitz Eins Baugruppe in Berlin. It's by 3 different architects. Again, you'll notice that these are mostly cellular, single unit, maybe 2-bedroom units. Up here, there's a diversity of units. There's 2 bedrooms, there's 1 bedroom, there's 3 bedrooms, there's 4 bedrooms. You have units that have cross ventilation. You'll notice all the bedrooms are kind of on the quiet side of the building. There's a lot more variation, and I think that there's a lot more livability that's inherent in a building like this. This stairway here, you've got 2 neighbors. If it's 6 floors, this is your building. There are really only 12 households that you directly interact with on a daily basis. There are like 20 units on this 1 floor alone. So it's, in thinking about how families reside in a city, like for me, like this, and we lived in a wonderful 4-plex in Bavaria, having that kind of intimacy really made knowing our neighbors a lot easier. And then this, I'm just highlighting the circulation. And again, this is 3 different units, mix of unit types. I think there's some maisonettes, light on multiple sides. And so for the report, there were a couple of case studies that we put together. This is a Frères Architectus in Paris. This is this really elegant 9-unit plus commercial infill building in kind of Haussmann, Paris. It's a mix of units from studios to 3 bedrooms, incredibly cost-effective infill compared to anything you would find in the US. Really small parcel, it's 2,300 square feet and 9 units. There's no car parking, which again, in terms of thinking about carbon emissions and everything else, for me it's wonderful. There's a little bike room up the entry, and it meets the F energy, which is, it's not quite Passivhaus, but it's their low energy standard. And then here's the plan on the 2-bedroom side. So again, it's a really small parcel, postage stamp, 2-bedroom studio. Here's your circulation. And if this was required to have 2 stairs, you're not getting a lot of units, not getting as many units in this building. And then most of your building is going to be circulation. This is a really wonderful Passivhaus triplex. I believe it won an award through PHI a couple of years ago by Hall of 58. It's 3 stacked flats. They're all 3 bedrooms. I love this. This is the south side, functional deck that doubles as solar protection, and then they have additional layers of active solar protection as well. I believe it wasn't built with an elevator, but it can be retrofitted. And you'll notice here that the stair is actually pulled outside of the thermal envelope. And so we're not having, as Passivhaus folks, this could be open, it could be semi-conditioned, but we're not having to deal with like the heat transmission and the expanded surface area of that space. I think that's actually really critical in thinking about low and mid-rise Passivhaus going forward. There are implications for elevator pressurization and all kinds of things. So again, it's basically the same floor plan on every level: master bedroom, kids bedroom, kitchen, dining, living. It's not massive, but for us as a family of 4 with 2 kids, like this would be ideal. But it's almost impossible to find anything like this in Seattle. And also through the report, we were connected with public architecture and communication in Vancouver, who are working on Vienna House. Vienna House is being built in Vancouver. Vancouver House is being built in Vienna. And so there are firms that are kind of collaborating on these projects, really wonderful projects, social housing. They're aiming for Passivhaus, wood construction, prefabrication, 6 stories, 100 units plus amenities. And it's a single loaded corridor wrapped around a courtyard. Like it's actually, considering the constraints in Canada, like this is a super elegant building. And I kind of wish like this was the standard everywhere. But I was asked to take this building and look at like what it would be under the German inspired, point access block. And so I kind of took their plan and, try to keep the same number of units per floor, but take it to what you would see with like connected point access blocks. So the yellow are our circulation cores. I've added the corridor to kind of match what we could do in Seattle. And so you get some units with cross ventilation. You get a variation in unit size: studio, 2-bedroom, 3-bedroom. Excuse me. There are 3 additional elevators that would need to be added. The public's design has 2. But what's interesting is the FAR decreased by 22%. So the amount of built area or charged built area decreased by almost a quarter. And then also the exterior envelope was also decreased by a quarter. So there are significant cost implications for both of those moves, or savings potentially. The other thing too is with the single loaded corridor, the elevators are in one section. And so if you're mobility challenged, right, you have a much longer kind of path. And I don't know the exact layout, right, but I'm just saying, like, if for some reason you lived on the opposite corner of the building from the elevators, there's a much larger path or longer path to those units than you would find in a point access block. So kind of thinking about, livability, accessibility, flexibility. And here I've got a overlay of the 2 thermal envelopes. So the yellow is the thermal envelope for Public's original design for Vienna House, and then the black outline is ours. There's a 15% decrease in the heated floor area. So again, there's less space that we're heating. It reduced the compactness by 8%, and then all of this open space, this courtyard, becomes a little bit larger. So that there are these trade-offs that I think a lot of European projects can have, or even Japanese, Mexican, that we don't really have the option for here. And going back to like Passivhaus and compactness, right? So we're really talking about these buildings that are kind of in this range, the 0.5 to 0.2 compactness ratios. And for me, like, it's these two. It's the perimeter block development. It's the infill, like, you know, 5, 6, 7, 8 stories, point access block, just super efficient in like every way. From an energy standpoint, cost savings are possible if you can get the single stair building. Building construction costs, you can't really compare to Europe and the US because like Europe is just wildly better. And then there are zoning code implications, right? Like, it's, you know, we're not getting the possibility to do a lot of buildings like this. And then also from the Passivhaus standpoint, the treated floor area of a corridor is, you know, it's discounted at 60% chargeable. So if you have a double loaded corridor building and you're comparing it to a point access block in the double loaded corridor building, the corridor ends up being an additional 600 square feet. Well, you can only count 360 of it towards your TFA, right? So your energy reference area becomes affected by the type of building access that the vertical access that you're using, which like years ago I would never have thought of, but now it's like, oh yeah, that kind of makes a lot of sense. And also thinking outside of the box again. So putting the vertical circulation, the staircases outside of the thermal core. This is the 82. It's a Passivhaus, mass timber, Baugruppe in Munich by Nest Eco Architecture. It's super elegant building. You know, cross ventilation, mix of unit sizes, 2-bedroom, 4-bedroom. Right. So it's like kind of thinking about like, you know, more flexible uses. It definitely hits those. And also thinking outside the box. This is a stunning retrofit from a building in the 60s with a single loaded corridor, but it's taking that single loaded corridor and really just expanding it to kind of be this social condenser space, garden, a space for, you know, residents to go outside and kind of be protected from the elements. So it's kind of like a winter garden, but you could also open it up. It's also noise mitigation, right? So you just thinking outside of the standard of the double loaded corridor, I think opens up some really kind of wonderful opportunities. And you know, in terms of embodied carbon, Aufstockungen, vertical additions. This is a 4-story single stair building in Vienna. And then Joseph Feichenberger came in and added 3 more stories. And the way that this works is the single stair building is effectively legal to 8, 10 stories. You're just extending the staircase and the rating of that staircase and that access, you know, to access the new floors. You're not having to come in and carve out space for an additional stairway. And so there's, you know, when we're thinking about like general urban renewal and recompacting the city, like there's some really elegant opportunities that this opens up. And again, mitigating noise. So going back to some more of the livability components. This is Alles für Gut. This is a project that's almost finished in Munich on Ludelstrasse. 373 homes, this daycare, there's the youth center, this traffic calmed interior, and they're using the buildings to basically be like this barrier, you know, to the highway it's effectively located off of. And we don't really think of this in the US. This would just be thick building the whole way, and these people would always be on the loud side, and these people would always be on the quiet side, but maybe not get any sun. And so there's just a shot of the interior, right? Like, I'm a big component of quiet, car-free spaces, like especially in cities. And so as we're thinking about the climate crisis, right? Like, so we have the wildfire smoke season now. We had a heat dome. There's rampant flooding everywhere, it seems. It feels like the US industry is like wholly unprepared for all of this, right? We don't have passive house mandates. We're not using buildings as cooling centers or fresh air centers to the degree that we could. We don't have external shading on our buildings, right? And so like passive house for me is kind of like this catalyst for thinking beyond kind of the status quo in terms of not just how we build, but how we live. And so like Ken said, looking at the larger scale. So we had a bunch of light rail stations that opened up recently. This is a planning study by a local firm here. This is the light rail station, ton of parking, really thick buildings, not a lot of open space. All these buildings, if they're not offices, are going to be largely double loaded corridor buildings. And so you're going to have a lot of, you know, studios and 1-bedrooms. You're not going to have a lot of economic and social mix like you see in other places. It's not a lot of open space. Again, Roosevelt, here's our light rail station in Seattle. These are mostly 3, 4, 5, 6-story buildings. It's like no open space was added. It's a little bit of social housing, no slow streets, no pedestrian zone. But like, what if we were to like change the way we think about developing, right? And so we have like these brownfield developments with thin buildings, so you can have cross ventilation, so you can have daylight on multiple sides, your bedrooms on the quiet side, so you can have a mix of Baugruppen and co-ops and social housing instead of 95% of the buildings being market rate housing. You could have open space. You could have space for daycare integrated into the community, connected to transit. This is the Southern Viertel in Vienna, a bunch of passive house buildings here. It's a huge project, 13,000 residents and 5,000 homes. There's space for 20,000 jobs. There's a huge educational campus over here. The buildings are effectively acting as a sound barrier to keep the park relatively quiet. Here along the rail, it's a lot of car parking and parking garages. So they've kind of pulled the parking out of the development to really kind of reinforce this kind of quiet interior, this livable interior. There's a pedestrian zone, there's shops, there's restaurants and cafes, and a tram runs through the middle of it, right? It's like, this is beautiful. I can totally see myself living here with my kids forever. And there's affordable social housing spaces, there's affordable co-working spaces, artist studios. It's really like, how we design cities needs to change dramatically. So for me, it's like the eco district becomes a carbon sink. And I love this. How do our codes affect our quality of life? The Shining, the double loaded corridor, right? This is ubiquitous in American architecture. But the rest of the world can do stuff like this. This is a Baugruppe in Vienna. Seestern, it's the units open directly into the stairwell. There's a skylight above with that can exhaust for fires. It'll exhaust the heat and the smoke. It's daylit. Your neighbors, you can see them. It's communicative. Like, there's something that's really amazing about this, and our codes just don't really allow it. But we need to change that, and we need to change it fast. So that's what I have. Homage to Liz Warren on top. And yeah, do we have any questions? How are we doing on time?
We're doing good. Great job, Mike. Do you want to stop sharing?
Yeah.
Let's see if I'll spotlight myself. Yeah, that's fabulous. So inspiring and equally frustrating, I think, a lot of times when you get exposed to this.
Yeah.
So we definitely have some questions here. And I think one of the things that I just took away there at the end, you're talking about thick buildings bad, thick walls good.
Yes.
Right?
Yes.
So it depends on what we're talking about, the context there. So let's dive in here a little bit. There are a couple of questions around construction differences between Europe and the US and costs, relative costs. If you could speak to that. And also I'm wondering if you have a handle on the issue of, where you're grouping the smaller number of apartments together, you need elevators, you obviously are losing some cost efficiency there in the construction. But at the same time, you're getting greater compactness and you're getting efficiencies, hopefully, in the overall building construction. I'm wondering if you've seen those things balance out. So 3-part question there.
Yeah, so let's take the first part. The construction cost, it's so difficult. Like I'm constantly throwing up projects that are social housing, passive house, mass timber, things like that in other countries, specifically Austria, France, and Germany. And their construction costs are half of what we build for in Seattle. For like a code minimum, building in Seattle is vinyl windows. It's not wood windows. It's not a passive house. We have a couple of projects that'll be mass timber coming underway. I think Susan Jones is on here. So we're like moving in the right direction, but like our building codes and our energy codes aren't really pushing things in the direction that they need to at the scale that they need to. And on top of it, we don't have the industry set up the same, right? So like passive house windows in Germany, there's basically no cost premium to get passive house windows because, that's almost the baseline of your window package now. Whereas here in the US, like the 2-pane leaky vinyl window and a passive house window, like there's a huge disparity, in terms of cost. So I think that there's a couple of things. There's also like social healthcare likely plays a part. I've talked to a couple of architects in Germany that say contractors and investors don't make the same return as they do in the US. So, finance rules everything, and in the US it ruins everything. And so, there's kind of that I think that plays a role as well. What was the second question? Sorry.
Well, there's related to the cost was the different construction types between the US and Europe.
Yeah, so a lot of, I would say a lot of the projects that I'm familiar with in Europe are probably comparable to what you would see in New York City with like the block and panel, or it's block with poured concrete. Like concrete is everywhere. Wood frame construction isn't super common. It's big in Bavaria right now. It's France and Amsterdam have like, bio material mandates, and so it's picking up there as well. But it's not super common. I mean, there are a bunch of projects, but it's not relatively common. But the thing that's interesting is that there's a slight premium for doing mass timber over concrete, but there are efficiencies being made. It's faster. You're not having to have as much insulation because it's better at reducing thermal conduction than like concrete would be and stuff. So it's a little bit different. Wood frame definitely isn't the norm, whereas even here, like with 5/1s, right, most of that is wood frame construction.
Yeah, no, good point. And then just could you speak to a little bit about, I mean, it seems like if you can get the economics to work, the developer's happy, at least in terms of a pro forma, to move ahead with this direction, at least myself, imagining I'm a developer right now.
Yeah.
So what are the roadblocks there, and just on an economic perspective, to making this type of setup work?
So elevators in the US, I think, run a little bit more expensive than in Europe. There are potentially other issues, maintenance, power. I think the trade-off is, if you're looking at a 5 to 8 story building, the increase in floor area that you have that you can now rent or sale or lease or sell, in doing the ROM numbers, like it offsets the cost of the elevator, right? And so I think that there's kind of like this cost equalization that happens, like you're changing basically hallway for living space, and that kind of pays for the cost of the elevator increase. The bigger issue is it's the building code, right? Like you just can't do multiple elevator point access block buildings in the US yet.
Right. So for your research for Vancouver and in relation to the codes there and what they're dealing with, like, is the intention to see how they can change the codes in Vancouver?
Yeah, so they're interested in looking at a means of unlocking kind of that low-rise development with point access blocks. Conrad Speckert is on here. He's the second egress.ca. He is working with some code guys as well, I think on the national level, to kind of push for those changes. What's really fascinating is after I wrote my report, like people came out of the woodworks in Canada, in the US, saying like, oh my God, this is really cool. How do we do this here? And so it's not a quick change process, but it does seem like there is some movement on it. And Conrad speaks really well to the difference in fire department responses. Here in the US, it's more building saving, and in the rest of the world, it's kind of more saving people. And so, that there's some insurance and liability issues, I think, around that we need to change as well.
Yeah, great. Yeah, it seems like it's going to be a feedback loop. Hopefully the feedback loop is quick with that. There were a couple of questions around egress, which is definitely top of mind. One around suggestions to how to deal with the second means of egress requirement, besides adding a second stair. I believe in New York, it's been a while since I've practiced, you could add a sprinkler system in lieu of a second stair. And there's a related question about the often required ground level egress courtyard to connect to the public way, doing the Seattle special in quotes.
Yeah, that's the Seattle's, so they allow up to 5 stories, 6 with a separate use on the ground floor or parking. It's a good question. We have the sprinkler requirement. We do have rated buildings. I think the exiting is kind of the same as with other buildings. You just have to have, once you're clear of the building, that's not counting towards your common path of egress travel. It's just your exit. So
right. Good. And in terms of inventive ways of dealing with the two means of egress, I don't know if there's anything.
If you do have the two means of egress, is that what you're asking?
Yeah, just in lieu of how to deal with the second means of egress, besides adding a second stairwell. That would be the sprinklers, right? Or
Yeah, I mean, we're required to do the sprinklers.
oh, you're
If we don't,
required.
yeah, we're required to do sprinklers for everything now, even
Okay,
townhouses.
right,
It's kind of nuts.
right. We have comments here. Let's see. Pull out. Big argument in the UK is replacing buildings with 100+ years of embodied carbon with new build, that the new build has to not add the embodied carbon. So timber seems preferable for that, but not widely accepted. I guess more of a comment than a question in terms of shifting construction preferences, perhaps.
Yeah, and the UK also had, they were fighting to allow multi-story wood buildings. I think that was going to go away. Andrew Waugh and a couple of other folks were involved in like lobbying the government to basically keep allowing them. England is an interesting case because most countries aren't allowed to do single stair buildings as tall or near as tall as the UK. The UK, there's actually no limit on single stair buildings, and so like Grenfell was 24 stories. You don't really find that anywhere else in the world. There was just a facility, it was a skyscraper in London, I think, that was going to be a single stair building, and the government shot it down. I mean, I think there are limits to how this is applied, and like, you know, most of Europe doesn't use sprinklers for multifamily buildings unless they're, you know, high rises. You know, so it's kind of, for me, it's like I wouldn't really feel comfortable above the 6th or 7th story, but you know, Germany 8, 10 stories, it's
Right.
legal. So
I mean, in New York, I think people get nervous when they don't see the second stair off of the same floor.
Yeah.
It's remarkable, definitely. Well, you just hit on one of the questions that came in. There was a note about the relationship of the single point access and co-housing, and kind of the chicken and the egg. What's the relationship with it? Is it point access kind of existing and co-housing as natural use and adaptation of it, or do we see point access being really held up with co-housing? Like,
I would say the kind of the urban co-housing projects in Europe that I'm familiar with, the urban ones, a lot of them tend to be point access blocks, but that's just that's really the default mode of construction of planning a building. There are also a bunch that are single loaded corridors. I can't think of any that are double loaded corridors. And again, like, I think it speaks to, you know, Europeans are already better at living in denser environments. But if you're living in a denser environment, like, you know, sharing a building with, you know, 12 people instead of 100 people, you know, for us, it seems like it's kind of an interesting approach. So.
Right. Do they deal with roof access in terms of egress? Is there
Like
workarounds?
With roof decks?
Yeah.
Yeah, so it's a really interesting mass timber Baugruppe that was built in Berlin a couple of years ago. It's 2 connected point access blocks that both go up to a roof terrace. And so there's this, you know, the second means of egress, potentially you could go up and over, right? But there's 2 means of egress from the roof. I would say roof decks aren't super common in a lot of European projects. I'm trying to think of, there are a couple of buildings I can think of that have them, you know, but they're relatively small. You know, here in Seattle, we cover like the whole building in a roof deck.
Right. Yeah.
Because we have to have 2 means of egress anyway, right? So it's just like more amenity space.
Where do you see opportunities with this? I mean, some of the obstacles seem obvious enough around the code and some of the expense, but do you see a use type that's low hanging fruit? I mean, co-housing might be an answer, but what?
Yeah, you know, who is the
What's the sweet spot here?
Vishan Chakrabarty. did a proposal for kind of like affordable decarbonized buildings. I think it came out last year, the year before, and it was 3-story, family friendly, car free, wood framed, low energy buildings. With the way the IBC is set up, like I think really the big opportunity is in like that low rise area.
Right.
In Seattle, I would love to do more kind of, for me it's mid rise. Like low rise is fine, but I'm a mid rise person. I like Berlin, I like Vienna, and so it's we have kind of the opportunity to do that in Seattle. The bigger issue is just like where you can do it is severely constrained, mostly on
Right.
arterials, which I don't want to live on.
Right.
So.
And the low rise would seem to lend itself to the co-housing kind of model in that you're building this intentional community. If you have the space, right, in a exurban or buffer area.
Yeah, I think the low rise and the mid rise, I think work really well for co-housing. There's a 5-story building here in Seattle. It's like 4 on one side, 5 on the other. Kind of infill, single stair, co-housing building by Schemata. So.
Yeah, could you speak? There's a question about just speaking a bit more to the relation, what you see with co-housing in terms of the building typologies and the single point access.
Yeah, for me, it's really,
or otherwise.
Yeah, it's the it's kind of the quality of life that you get with a point access block. I think is going to be far superior than with a double loaded corridor building. It's co-housing doesn't really work above like 20 or 30 households, right? And so, if you have a building that has 20 units per floor and it's 6 floors, and most of them are going to be single units, right? Like it's a different kind of environment than if you're in a building with 4 units per floor. They're all 2 and 3 bedrooms and it's 5 floors, right? Like how we plan our buildings and how we zone and everything else, I think it really affects livability, but it's not a question that's on anybody's mind, and it's a constant point of discussion in the EU, like in Germany, like how we live, how we want to live. It was a conversation that was happening everywhere.
Yeah. Great. I guess, I mean, in terms of the obstacles that we see that are out there, what really is it where we're identifying project types, typologies that it could work? Is it really economics? Is it just unfamiliarity? How do we get these ingredients to work together?
It's a little bit of everything. The economics in the US in construction is just off the scale, ridiculous. The building codes aren't quite there. The zoning codes aren't quite there. But I don't know that it would take a lot of, like, if everyone adopted what Seattle did, I think that would be a pretty transformational change. And if everybody,
speak more to that?
What's that?
Well, can you speak more to that?
Yeah, so in Seattle, we can sort of do 6-story buildings with a single stair. We can do 2 per lot. So you could have a building that is 5 times 4 is 20 times 2 is 40 plus 8 live works, or maybe it's commercial spaces. So you're talking about a 40-unit building of everywhere from studios to 3 or 4 bedrooms if needed, right? Like you don't really have that opportunity in the status quo method of developing buildings.
And there is significant uptake. I'm not familiar.
There's, it's funny. There hasn't been, but in the last couple of years, there have been a number of projects that have started to go this route. And they're all on like these postage stamp sized parcels. But right. It's kind of, if that's all our zoning code allows, then, maybe that's a net good. But it is something that, we're trying to develop Bao Group or urban co-housing, at least a model, hopefully the real thing. And, it heavily relies on the point access block in terms of, getting the economics and the unit mix. And, we want it to be affordable, to like everyone under 100% AMI. And so to do that, if we had, double loaded corridor in a huge building, it's just not feasible.
Right. Fantastic. Well, this is wonderful, Michael. Really appreciate you sharing this with us. I love seeing Passivhaus applied to these Passivhaus context, so to speak, like just how it can be part of our lives everywhere, as my kids seem to think Passivhaus is.
That's my kids feel that way about Germany. Everything goes back to Germany. Stop talking about Germany. So.
Oh, this is wonderful. This video will be made available online next week, a week from today. So check back in. I want to thank everyone for joining us today, and keep an eye out for the next PHN Presents in April. So we'll be announcing that shortly. Have a great day, everybody. Thank you, Mike. Fantastic.